In this tutorial, we are going to see gate question asked in CSE department in the year 2025. Two signed 2's complement numbers are given here. One is multiplicand M, which is of size 16 bits. Another one is multiplier Q, which is also of 16 bits. So these two numbers we are going to multiply using Booth algorithm. So the question is, how many number of addition and subtraction operations are required to find out the result? So they are not bothered about the end product. They are asking you to find only total number of addition and subtraction operations. To perform that one, we need to understand the basic idea behind Booth algorithm. How Booth algorithm is performing the multiplication means, we consider only the multiplier. In the multiplier, suppose if we take this as our current LSB, we are going to check our current LSB. If the current LSB value is 0, because we don't have any previous LSB, if we assume that it is 0, we consider a pair of bits in the multiplier. So the pair of bits only decide what type of operation we are going to perform. When both the values are 0, 0, I mean the current LSB bit and the previous one, a pair, we consider those two values are 0, 0, we perform only arithmetic shift right operation, no addition or subtraction. Similarly, 1, 1 also tells us that only arithmetic shift right operation to be performed. Other than these two combination, if it is 0, 1 means we perform addition, followed by this we perform arithmetic shift right. If it is 1, 0, we perform subtraction. Subtraction means accumulator value minus multiplicand, the result will be stored into accumulator. Followed by this, we perform again arithmetic shift right operation. So in every cycle, we perform arithmetic shift right operation. Depending on the pair, if it is 0, 1, we perform addition, then shift right. If it is 1, 0, we perform subtraction, then shift right. Other than this, if I have 0, 0 or 1, 1, don't perform addition or subtraction, simply perform only shift operation. So this is what rule of the Booth algorithm. In order to understand the rule, let us have a simple example having 3 cross 3 numbers. I have taken two 3-bit numbers and we are going to perform multiplication using Booth algorithm. So first one, multiplicand, I have taken the value of 101 because the first digit is 1. In 2's complement representation, it denotes a negative value. And if you want to calculate the actual magnitude, take 2's complement and put a minus sign. So its value is minus 3. 101 means minus 3. I have taken multiplier as 110 and again the first bit is 1. The actual value is minus 2. So multiplying minus 3 and minus 2, we supposed to get 6 as the result. Right? We are going to perform with the help of Booth algorithm. For that, what we do, we take an accumulator which is same as that of the multiplier. So multiplier is 3 bits means accumulator also must be 3 bits with an initial value of 0. This is where upper 3 bits of the results will be stored. The lower 3 bits of your product, that means the end result, will be stored in multiplier itself. So total 6-bit results will be stored in the combination of accumulator and multiplier. So I have taken accumulator, multiplier with a given value, and we also assume one more bit called Q minus 1. This is for performing the Booth multiplication. We need to have pair of LSBs. When this is my current LSB, I don't have any previous LSB. For that, I am assuming the LSB value as 0 for this moment. In later cycles, whenever I shift, I automatically get the previous LSB values. So at the first cycle, we are assuming its value is 0. After filling this, the pair, LSB pair, tells us that it is 0, 0. What type of operation to be performed for 0, 0? According to the table, arithmetic shift right. So no addition, no subtraction, only arithmetic shift right. And the given value is this. Shift right means it is arithmetic shift right. So keep the symbol as such. Don't change the sign. If it is 0, I mean positive, you keep that as positive. Don't change the sign. and then start to move the bits one bit right. So the first one moves to second position, second one moves to third, third one moves to fourth, and so on it moves. Finally, the previous LSB, the last one 0, moves to the Q minus 1 position. Now you check the 2 after shifting. Now you check the 2. 1 0. For 1 0, what type of operation to be performed? According to the table, we have to perform subtraction. Either you do subtraction with multiplicand or you perform addition with the complement of the multiplicand. Here complement means 2's complement. For 0, 1, 0, 1, 2's complement means first you perform 1's complement, it becomes 0, 1, 0. 2's complement means we need to add 1. So it becomes 0, 1, 1. 0, 1, 1 means its value is 3. Right? So this m bar we have taken. So we are going to add with the m bar. This is going to be our second cycle. In the first cycle, we have got 0, 0 as the pair. We performed only arithmetic shift right. In the second cycle, we are given with 1, 0 as the pair. So for this 1, 0 pair, we need to perform complemented addition. So this is my accumulator value, and complemented value of multiplicand is 0, 1, 1. You perform addition between the two. So you get the result like this. And this is our multiplier value. And the value in the LSB bit, the additional LSB bit remains same. After performing the addition, I mean complemented addition, once again you perform arithmetic shift right. Arithmetic shift right means keep the sign as such, move the bits one bit right position. Right? So in that way, if you shift, now we are ready for the third cycle by checking the current LSB and the previous LSB which gets shifted and moved into Q minus 1. So the current combination is 1, 1. 1, 1 also tells us that we need to perform only arithmetic shift right operation. So perform arithmetic shift right. According to this, the current value is this one. Shifting right means this one comes here, this one comes here. One bit position we shift right. The first bit, what we are taking is the sign bit. Previous whatever may be the sign bit that we are copying here. Because it is a 3-bit multiplication, we perform the operations only 3 cycles. First cycle, only shift right. Second cycle, subtraction followed by shift right. Third cycle, shift right. Finally, whatever the value we have in the accumulator and the multiplier, that is nothing but our answer. So here it is 6. The product of -3 and -2 is equal to 6. We have arrived at the result. So this is only a sample multiplication process in order to understand Booth algorithm. Now let us come to the actual problem. In the actual problem, we are not going to perform any multiplication. We are simply going to identify how many operations we are going to perform. For that, we need only multiplier. We need not even consider multiplicand for performing addition or subtraction. So I have taken the multiplier here. Our current LSB bit is 0. In order to have LSB pair, we are introducing one more bit, right? So I am introducing that bit as Q minus 1 and its initial value I am taking as 0. This 0, 0 pair tells what type of operation? It is shift operation, arithmetic shift right. So after performing arithmetic shift right, we get this 1 moved to here. It moves one bit right means, so 1 comes here. This 0, that comes to here. The current LSB position what? The current LSB position is 1, 0. So after performing the first one, the current LSB pair gives you 1, 0. 1, 0 means we perform subtraction. Afterwards, we will have a pair like this, 0, 1. 0, 1 means addition. Again, we need to have a new pair, 1, 0. So like that, if you continuously go on performing the operation, then it gives you what type of operation to be performed, whether addition or shift operation or subtract operation, all these things that we need to carry out for 16 cycles. Why? Because the size of the multiplier is 16 bits. So we continue for 16 cycles. Out of 16 cycles, in 3 cycles, we have the LSB pair values as 0. So 0, 0 means we perform only shift operation, no addition or subtraction, only shift operation. In rest of the places, we perform subtraction followed by shift operation or addition followed by shift operation. So all together, Out of 16 cycles, 3 cycles we perform only shift. Remaining 13 cycles we perform addition and subtraction followed by shift. If you consider total number of addition and subtraction, it is going to be 13 times we perform in order to calculate the end product or end result.